Here's another hello from West Virginia. Obviously not. Okay, but what is obvious is we're going to do Joke of the Day because I know that you're waiting and you love Joke of the Day. So why are giraffes so slow to apologize? I mean, why does it take them so long to apologize? Because it takes them a long time to swallow their pride. It would take them a long time to swallow anything, wouldn't it? Okay, well, we are going to swallow into adding and subtracting sign numbers and their applications. We now know how to add sign numbers and subtract sign numbers. And remember, when you're adding sign numbers, the whole idea is to first determine what the sign of your answer is going to be. And if the signs are the same, keep that sign and just add up those digits. If the signs are different, then you're going to ignore the digits. And then you're going to take the smaller digit from the larger digit, and then in order to determine the sign of your answer, you're going to still ignore those digits, and you're going to take the sign of the larger digit. That will be the sign of your answer because the larger digit overpowers the smaller digit. And then when it comes to subtracting sign numbers, remember what you're going to do is you're going to kick it back to addition because you know your addition rules, you're good at the addition rules. So let's just add the opposite of the second one, change your subtraction into addition, add the opposite of the second one, and go back to those addition rules because that's what you know how to do. But now what we're going to do is take a look, why are we learning all this stuff? What difference does it make? And I've got two examples of real world situations where something like this would be applicable. So take a look at the first example. It says, during a drought, the level of Cottonwood Creek dropped 18 inches. Then there was a storm and it rose 2 inches. Later, the level of the creek dropped 4 inches. We want to know, what is that net change? This kind of goes back to that idea when I was explaining how to add sign numbers and I was talking about football, even with subtracting the sign numbers. I said, what's the net change here? Similar idea. So if the level drops 18 inches, well, how would we represent that it's dropping? Yeah, that would be negative. So that would be negative 18 inches for the drop. And then notice, remember it says we've got a storm and it rose 2 inches. Well, how would you indicate rising? Yeah, that would be positive. So I'm going to take that negative 18 inches and I'm going to add positive 2 to that. And then it says after that it dropped again 4 inches. So once again, to represent dropping, we would subtract 4 inches. And we want to know, what is the net change for all of this? Well, you know that we can only work with two numbers at a time. So we're going to work with the first two. And I'm adding a couple of sign numbers. Notice the signs are different. One's a negative, one's a positive. So remember, what that indicates is I'm going to ignore the signs at first, and I'm going to take the smaller from the larger. So I'm going to take 2 from 18. That would give me 16. And to determine the sign of the answer, I'm going to take the sign of the larger digit. Well, the 18 is larger, so I'm going to take its sign because it overpowers the 2. Its sign is negative, so therefore negative 18 plus 2 will give me a negative 16. But now what I'm going to do is I'm going to take this negative 4, drop it down there, and combine these two. And remember, with a subtraction problem, what I'm going to do is I'm going to turn it into an addition problem, and I'm going to add the opposite of the second one. This is currently positive. So I'm going to add a negative, and now when it kicks it back into that addition problem, I go back to those addition rules again, and I go, okay, signs are the same. So when signs are the same, I'm going to combine the digits, and I'm going to keep the sign. So I'm going to combine the 16 and the 4 and give me a 20, and I'm going to keep that sign of negative. So it's a negative 20 what? Yes, inches. Remember, it's very important to include those units when you're dealing with real world situations. So this is a negative 20-inch net change. So does that indicate that we have a net rise or a net drop? Yes, a net drop. And that's the importance of including that negative in there to show that the level of the creek is dropping as a whole, and it's dropping 20 inches. Okay, so let's take a look at another example. And in this example, notice that it says U.S. international trade can be approximated by the equations E equals 0.04 N plus 0.7. This represents exports in billions of dollars. And I equals 0.09 N plus 0.8. And this represents imports in billions of dollars. And also, we need to emphasize that that N represents the number of years after 1994. So this is the U.S. export equation, and this is the U.S. import equation. And so now we've got 3 questions to answer based on that information. Now the first question says, how much was exported in 1998? Well, in order to figure out the answer to that, we would have to utilize our export equation. And so I'm going to utilize my E equals 0.04 N plus 0.7. And remember, that N represents the number of years after 1994. Well, I'm talking about 1998. So how many years after 1994 is that? Well, that is 4 years. Because if I take 1998 and I subtract 1994, that will give me 4 years for my N. So that means that I'm going to take this N and I'm going to plug a 4 in there. So I have 0.04 times 4 plus 0.7, and I'm going to follow order of operations. Order of operations says do the multiplication first. So 0.04 times 4 is going to be a 0.16 plus 0.7, and 0.16 plus 0.7 is going to be a 0.86. Now that's 0.86 what? Yes, go back to what the definition said. It said that the E was going to be billions of dollars. So first off, I need to include my dollar symbol in there, definitely. But be very careful, because as this is written, that simply says 86 cents. That does not say billions of dollars. So I need to include that billion in there, and realizing that that is $0.86 billion worth of exports. Now let's take a look at the second question. How much was imported in 1998? Well, it's the same year, so I know my N is still going to be 4 once again, but now I'm looking at import. So that's going to be the second equation. I equals 0.09 N plus 0.8, and once again the N is going to be a 4. So I'm going to plug that 4 in there, and once again I'm going to follow this order of operations, which say let's do that multiplication first. Whoops, not an E and I apologize. So 0.09 times 4 is going to be 0.36, and when I take that 0.36 and I add 0.8, then I'm going to get a 1.16. And once again, 1.16 what? Go back again, yes, billions of dollars. So I include my dollar symbol, but once again, be very careful because that looks like $1.16. No, this is not $1.16 worth of imports. It's $1.16 billion. So now the last question says, what was the trade deficit in 1998? Well, we need to figure out what deficit means. How do you figure that out? Well, remember, exports is what the country sends out. So if this is U.S. exports, then the U.S. is sending their goods out, and so other countries are buying those goods. Is that good for America or is that bad for America? Yes, that is good for America because we're making money off of our exports. When other countries are buying us paying us for our goods, then we're making money off of that. So we're making money on exports. However, imports are goods that we bring in. So goods that we bring in, we're paying other countries for their goods. So is that good for the U.S. or is that bad for the U.S.? Well, it kind of depends, but as a whole, that's probably kind of bad for the U.S. only in this sense. We're paying out. We're not making money, we're paying out. So what we want to happen is we want our exports to be greater than our imports. We want to bring in more money than we are sending out. So let's see how this is working. So it says that we're in a trade deficit, and you can see most definitely we are paying more than what we are bringing in. So what I'm going to do then to figure out our trade deficit is I'm going to take this $0.86 billion and I'm going to subtract the $1.16 billion. And I know you may be thinking, why are you doing it that way? That makes no sense. You'll see here in just a minute. Now remember, when I'm subtracting, that's the same thing as adding the opposite of the second one because that kicks it back into an addition problem. And so I'm going to add, currently it's positive, so I'm going to add a negative. And so what that gives me is 0.86 plus a negative 1.16. Since the signs are now different, I'm going to take the smaller digit from the larger digit. And when I take 0.86 from 1.16, I get 0.30. Now, here's the question. Is that negative or positive? Remember, take the sign of the larger digit. The larger digit is negative, so I'm going to take its sign, and I'm going to make this negative. Now, here's the big question. Negative 0.30 what? Yet again, yes, this was billions of dollars. This as well was billions of dollars. So therefore, this is going to be negative 0.30 billions of dollars. And once again, don't write it like this, because if you write it like this, then that only indicates 30 cents. This is billions of dollars, a whole lot of money. Now, a couple of things to mention. Why on earth was it important for me to make that a negative? Why could I not just simply have said $0.30 billion? Because it's a deficit. We went in the hole. To show that we went in the hole, it's important to show that negative in there. Because if it was simply $0.30 billion like this, that would show not a deficit. That would show an actual good situation. But we're in a deficit. We're in the hole. So we want to make sure that that negative is sitting there to emphasize that. The other thing is I want to point out to you how really large this number is, because 0.30 billion, well, that would be, billion's going to have, million's got 6 zeros, that's 9 zeros behind it. So, okay, so I hope that helps with understanding why we need to understand sign numbers and where they come from. Lots and lots of applications with sign numbers. These are just a couple of examples, but there are many, many that deal with sign numbers. So I hope that helps. Have a great day.